Next come the constraints. So I'm putting the decision variables together. I'm organizing them by column. I'm going to put the constraints together below the decision variables. So, but later we might put them somewhere else, but a pretty general rule is you want to keep the decision variables together in one area and keep the constraints together in another area. Now I like to match them up, and you'll see why when we put in formulas. But I'm going to put the constraints down here. Let's just call this constraints. If you put the cursor here between the columns, double tap it, it'll expand it to meet the maximum width of whatever is in the cells. Alternatively, you can take it and drag it wherever you want. Constraints. What's my first constraint? Pumps. I'm going to call it pumps. That's the name of the constraint. You can make up whatever's a meaningful name, but I want it meaningful so that whenever I later look at it, I know what this constraint is. It's the pump constraint. That makes sense. So recall from chapter 2 that, and you can see it on our math model here, constraints are in terms of what? Our decision variables. You see x1 and x2? Those are our decision variables. When I enter that in, the first constraint, pumps, each one takes one pump. That's why it's 1 times x1. I'm looking right here at the first constraint in this blue box. 1 times x1 plus 1 times x2. That has to be less than or equal to 200, which is the number of pumps I have. It really doesn't matter if I put 1x2 plus 1x1 or 1x1 plus 1x2, which way they come. Mathematically, it doesn't matter, but for my model, I want to match them up. I want the x1 right here underneath x1. I want the x1 variable in column B. I want the x2 in column C. If I have more of them, I'll put the next one in D and the next one in C and so on. So I'm still keeping in mind that I've got this organized by column. All the x1, everything to do with Aquaspa is in column B. Everything to do with Hydrolux is in column C. But now I've got an additional method here of organization where I have a constraint on separate lines. So the first row, this row 8, this is going to be my pumps constraint. It's entered in with x1 in column B, x2 in column C, but the next one will be the next constraint. So constraints are by row, and I'm organizing this decision variable by column. So keep that in mind. So the first one is 1 times x1. Well, let me just put the 1 in there. What I'm entering in are the coefficients. So let me just center all this. These are the coefficients. Later I'll go and enter in the formula, and I'm going to enter that in right here to associate the 1 with the x1. So we'll worry about that later. Right now we're just entering in the coefficients. So pumps and labor. And what's the next constraint? Tubing. So I have pumps, labor, and tubing. Those are my main constraints here. 1 pump each. For labor, it's 9 hours to make the Aquaspa. So I put 9 in column B, which is the Aquaspa column, and 6 for the Hydrolux. So 6 goes here in the column C under Hydrolux. And then for tubing, 12 for the Aquaspa and 16 for the Hydrolux. Okay? The multiply times the x1 and the implied plus sign, that'll all be done in a formula, which I'll put over here. That'll be my left-hand side of the formula. So look over here in the blue box. We have 1x1 plus 1x2. That's the left-hand side of the formula. I'm going to put the result in this box here, and let's shade it something. I'll make it kind of a light blue. I'm just making this just so that you see that this is these are inputs. Okay. Give it some borders. I'm going to give it a label. LHS for left-hand side. That sounds good. LHS for left-hand side. I'm going to move my model over here a little out of the way. And over here, I'm going to put my sign. So that'll be the left-hand side of and over here I'm going to say right-hand side. So let's center that. So right-hand side. Well, the right-hand side's pretty easy. I have only 200 pumps, so I'm limited to 200 pumps, and it better be less than or equal to 200 pumps. So I know my sign. I have 1,566 in labor. Do you see I'm pulling these numbers here from my mathematical model? So again, less than or equal to 1,566 and less than or equal to 2,880. That's the tubing I have. So that's my right-hand side. So that's it. If I want, let me go ahead and do this. These are non-negativity constraints for X1. Non-negativity for X1 and non-negativity for X2. I really don't have to put these in the model because when I go to Solver it'll take care of it, but I want to demonstrate one other thing here, and that's that the non-negativity constraint for X1, if you notice here in the blue box, it has nothing, there is no X2 there, and for the X2 there is no X1. So that's common. Sometimes I have a constraint that only pertains to one particular decision variable. So in that case, this one, 1 times X1, the 1 is implied, had better be greater than or equal to 0. In other words, I don't want to allow Solver to create negative aquaspas or Hydrolux. It might look at this problem and say, oh, well, Hydrolux, you don't make much profit, but boy, if we can make negative infinity of these things, then it'll free up so many resources. I can make positive infinity aquaspas, and then the computer will lock up, and you don't want that. Okay, so 0, I want 0 here. This is the same sign. I'm going to use the same formula. 1 there, 1 there. I could put a 0 under here in what is a C11, and I could put a 0 in B12 right here, but there's no need to because 0 is implied.